Thanks for inviting me to talk to your groups. And as is pretty much the law now, I'm going to be talking about AI, but I don't have any tools or services to sell you about AI. I just want to talk about AI to help all of us navigate our way through all of these things right now. So first up, a little bit about me and why you should listen to me. I'm Aidan Harding. I'm a co-lead at the Bristol developer group in the UK. I'm a principal architect at Akiva Labs. I've had 2 years of experience at a Salesforce ISV and 10 plus years in Salesforce consulting. And way back a long time ago, I did a PhD in computer science. And as you can see in the photo, I've got quite a nice fluffy dog who may make another appearance later on. So one of the things about AI that I want to start with is the context, really, that tools don't just live in an entirely technical world. They live in a context and a kind of social environment that we're in. And it's definitely true that we're in interesting times. Whenever we look at the news, there's all kind of bleak, bad, important things going on. And when we look at the tech news, there are lots of layoffs going on within the industry. There's this massive churn of AI tools. There's new things coming out constantly. The tools forever evolving. And within Salesforce in particular, there's the massive push towards Agentforce. So as we look at these tools, the way that ourselves and our teams and our colleagues react and respond to these AI tools is affected by all of these other considerations. And you know, they may be an opportunity, they may be a threat. There are all kinds of things at once because of all of these other things are going on. And when I mentioned in the title, developer thriving, that sounds like that's a particular term. And in fact, it is. There's a body of work by a researcher called Kat Hicks, who's looked with a sociologist's eye at how developer teams work. And one of the ideas from her research is that an aim for an engineering team is to have resilient productivity. So not just productivity in the sense of we can march really fast for a month and then we all collapse with burnout, and not productivity in the sense that we can slam a load of features into our product, build up a ton of tech debt, and then not be able to work on it anymore. We need resilient, healthy productivity. And there are certain factors that she found that contributed to teams being able to have this kind of productivity, one of which is a learning culture within their company. And that gives people the time and the space to experiment with different approaches and different tools and learn about these different things. And having a sense of agency within your team is also really important. We need to feel like we're in control of our destinies to some extent. And both of these things tie directly into how AI tools land with your team. And having a sense of belonging is important with your team. No one really knows exactly all the best ways to use AI tools. So we're going to make mistakes. We're going to look foolish. We're going to go slower sometimes before we can go faster. And if we've got the sense of belonging, and if we're in control of our destinies, and if we have a healthy learning culture in our company, then we're much better placed to make good use of the opportunities of the AI tools. And some of the things that are valuable to engineering teams are a sense of visibility and value within the company. The visibility of engineering within the company can be really important. Like sales teams are celebrated when they hit their targets. Engineering teams quite often can only ever really be high profile when things go wrong. But if we can make sure that their wins are celebrated, then they're in a better place to make use of these tools. And there's a real contrast between organizations that view engineering as a center of value rather than as a center of cost. So if we see engineering as a center for value, then AI tools should allow us to create more value. But if engineering is seen as a center of cost, then they're seen as a way to drive down costs. And I think we'd probably all rather work in an organization where engineering is seen as a value, not a cost. And measuring all of this stuff is hard. People say they can measure the productivity gains of AI, but no one's really been able to measure how productive an engineer has been at any time very effectively. So the more we can start to grapple the fact that measurement is hard, it's always going to be hard, it's better to do it than not to do it, and not to start measuring how effective AI tools without having a baseline of the effectiveness of how things are today. So before we get into the next things, I do want to talk about some success stories with AI. It is a tool that's useful. There are people out there who hate it and say that it has no use whatsoever. But to give you an example of something that I've been working on recently where I found AI enormously helpful is there's a project that I'm working on which is in 4 different programming languages across 5 different repositories talking to multiple different clouds. And I was going to add a feature into this system, and to be able to connect an AI agent to those multiple repositories and to look at the technical documentation for that code base and start to ask the agent questions about how this thing works and have it come back and say, yes, it does work like that. Here are the pieces of code where it joins up. No, you've got the wrong idea. It works like this. It's been a really powerful way to speed up getting on board with that system, getting a good understanding of how things work within there. And that's before I've even started to write any code. And an example of code where it's been super powerful for me was something I was working on recently where I found out after I'd written it that I had to make the language within the component international. So I'd written it all in English, and it had to also support Spanish. And I was able to say to an AI agent, take all the user-facing strings, separate them out so that we can have translations. And it correctly, in a web component, found everything in the HTML and in the JavaScript that went to the user. It left logging statements alone, but it picked out all the user stuff. It could even translate them for me. And it could even say, do you want Latin American Spanish or do you want Spanish? It was amazing. Super fast to get through that. It would have taken me a really long time. I did a great job. So there's no doubt that these things have some effective uses. And one of the things I love to do is they love to dunk on AI where it's gone wrong and it's failed, and they share pictures of how it's gone badly wrong. And I think sometimes when it's gone wrong, it's not the AI's fault. It can just be your fault. So sometimes you're the problem. First thing you should ask yourself if the AI hasn't done what you wanted is, did you actually explain what you wanted? Like one of the early metaphors that people had for these AIs is they're like an eager intern. And if you send them off to do a piece of work and they don't come back with all the documentation that you wanted, or they haven't done it in the style that you wanted, then it's most likely that you didn't actually specify what it was that you were after. And AIs are much like that. You need to make sure that you explain yourself. One of the other things is your code easy and predictable? One of the things people love to laugh at AIs for is where they make up method calls and API calls that don't exist. But sometimes those are actually clues to things that ought to exist in your system. And your team have just kind of got used to there not being certain methods that could be convenient, certain ways of manipulating things that would be nice to have. And actually, the more kind of ergonomic your code base is, the better the AI is going to do within it. Do you have good tests? Obviously, we don't know that we can successfully modify a system unless we can run tests to verify that it has maintained its old functionality and that the new functionality we've added works properly. Are you moving in small steps? If you ask an AI to do a massive piece of work, then it's not going to be able to do that very well in one shot, just the same as we do. Are you using source control well? It's really beneficial when you're working with AI tools to be frequently committing in source control and taking small steps. And when we merge our code into the main branch, we can squash those commits. So no one has to see all the step forward, step back. I tried this, it didn't work. It all gets squashed up. So it doesn't matter. It's not embarrassing to have all those steps. But if you take all those steps, you can always go back if the AI makes a mistake, and the AI can actually read the Git history of what you've been doing to give it extra context about what's going on in the code base. And if you look at that list of items overall, what you'll notice is that these are all things that we should have all been doing as good engineering practices forever. They don't actually only apply to AI. It's just that AI exposes any weaknesses in your software development cycle. It's like attaching a fire hose of code to your existing processes. If anything is a bottleneck or a leak, it's going to come spraying out when you attach AI to it. So if we nail these things, which we should have been doing anyway, then it really helps AI to be more successful. But it's not all good. There are ways that AI can deceive us and send us the wrong way. And I want to talk about flattery and the oracle problem here. So one of the things that we're used to is flattery, sycophancy, and overconfidence. So you will have seen, if you've worked with Claude somehow, you're absolutely right when I wasn't right. It just agrees with me too much. And it takes a resilience to understand that it's going to agree with you too much. And you kind of have to be watchful while you're working with these things to make sure it doesn't lead you down the wrong path. And it'll quite happily tell you that it's implemented X when it has not sometimes. You know, sometimes it will have done half the job, or it will have cheated somehow to leave half of it done. A lot of the time, a sort of guiding principle can be to get the AI to do things that you could do yourself, but it would take you longer. And then you're in a good position to be able to verify whether it actually did what you meant it to do. One of the things that's trickier about how AI can talk to you is the problem of the oracles. So sometimes AI will tell you something that's correct, but it's not exactly true in the sense that it doesn't tell you everything that you need to know. And the example I've got here from the world of literature is The Witches of Macbeth, which probably went down better in England, where you'd hope more people have read it. But the story there is that Macbeth is considering whether he will be able to murder the king and take power himself. So he goes to the witches to ask them for a prophecy about whether or not he should do that. And what the witches say to him is, "Be bloody, bold, and resolute. Laugh to scorn the power of man, for none of woman born shall harm Macbeth." So he takes that to mean, okay, well, I can go murder the king and take power and nobody can hurt me. And what happens in the story is that at the end of the story, he gets murdered by another person called Macduff. And the trick was that Macduff was born by cesarean section, not by a natural birth. So not strictly of woman born. So what the witches told him was correct, but it wasn't true in the sense of telling him what he actually needed to know to make the decision well. Now, that all seems a bit sort of tricky and, well, how does that really apply to code? So I was working with Claude Code one day, and I was implementing a browser-based OAuth flow in a Lightning Web component. And I decided to add PKCE parameters to it, which is like an extra safety mechanism where there's a server-to-server communication to make sure that the OAuth is correct. So if some bad actor is interfering with what's going on in the browser, the PKCE makes it safer to check that you are actually having the communication that you intended. So I asked Claude to add PKCE to what I already had there. It said it had done that, and then it listed out the steps that it had done to implement PKCE. So it said it stored the code verifier from the PKCE in the state payload. And it also said it had stored the code challenge in the authorization URL. And if you're looking very closely at what's going on, they've put both factors into the same channel. They've put the PKCE, which is supposed to be server-to-server communication, on the browser side. And this will compile and the OAuth flow will run, but a security engineer will tell you that this is not secure and you will fail your Salesforce security review, or some hacker will get in there. And much like the Witches of Macbeth, we've been caught on a technicality. And this close reading of what's coming out from the AI and this kind of wariness of, are things going wrong? And if you have this sort of suspicion, you can take the output of what one AI has created, stick it in another AI and say, does this look right to you? And quite often that's a useful second piece of information. And for myself, when I was going through this thing, I thought this looked dodgy and it looked like it was putting both factors into the same thing. And I just kind of stuffed the whole thing into ChatGPT and it said, yeah, you're right. And this time it wasn't lying to me, I think. And it had caused problems. So I had to go back and sort of re-implement this thing. So one question is, when should you use AI and when should you not? And I think one of the ways we can think about that is that sometimes the effort of the work is the point. So here's my nice fluffy dog again on the North Devon coast in the UK. And what we like to do is we like to go running around that coastline. And we run because it's fun, because it's hard, because it makes us healthier and happier. And you probably could get one of those weird, creepy Boston Dynamic robots to take the dog around the path, but that wouldn't be much fun for me. It wouldn't be much fun for the dog. I wouldn't get any fitter. The point of that activity is in the difficulty itself. And sometimes that's true of the things that we're doing. So AI can prevent you from learning if it's just constantly feeding you the answers, like a bad teacher that doesn't tell you how to work things out. They just take you straight to the end point. One of the other things that it can do is that AI can take your bad ideas and it can turn them into plausible code or plausible documentation. Sometimes, well, nearly all the time, writing is part of the process of thinking. And sometimes if you have a bad idea and you try and write it down in code or in documentation, you find it really hard to write down. And sometimes in the process of trying to write it down, you realize it wasn't a good idea or it wasn't fully formed. And the effort that you're making is making you understand your ideas better. And if you were to use AI, it would just very slickly produce some code that was actually an implementation of your half-thought or bad ideas when you needed to do the work yourself. But it is useful in terms of learning. One of the things that it's really good for is situations like where I was interrogating it about a code base. It's very good at translating ideas from one domain to another. If you're primarily well-versed in Salesforce and you need to do something in AWS or Azure or GCP, you can say, what's this called in this other system? I know this from Salesforce. What do they call it over there? And how does it contrast? And that can be a really good interactive way of learning something new. It's not shortcutting you to the answers. It's helping you to kind of explore the space of ideas. And it can, if the ground you've got to cover is boring, it can shortcut you to the good stuff. In the same way as I might take my dog for a 5-mile drive in the car before we get to the place we really want to go running. The same thing's true of code. If you need to do a load of kind of setup, boilerplate stuff, something that you really understand well, but you've just got to smash out the pieces, then AI is superb for that. You just got to pick the right places. So I mentioned friction, and sometimes friction is a really important signal in the evolution of your system. And it kind of impacts how we architect systems. When you architect a system, the amount of architecture and engineering you should do should be just enough for what's needed now, what's foreseeable for the next couple of years. If you do too much, you could be over-architecting it, wasting too much time now, focusing on problems that are not going to be your main problem in 5 years' time. And friction is what tells us when we need to adjust the architecture. If we're finding it increasingly difficult to add new features to the system, then we might need to re-architect how it works within the system. If the users are finding it too difficult to use the system and it's running too slowly, then that's another signal of friction that we should be thinking about re-architecting things. So if we're using AI tools to insulate us too much from that friction, then the system can go beyond the point where we should have been thinking about re-architecting it without people necessarily knowing. So we need to be aware of what these tools are doing. If it's taking your AI agent a really long time, a really large number of tokens to add things to your system, if you're looking at the output and thinking that diff looks too big for the size of the feature that I was expecting there, then that's the kind of thing that you need to pay attention to as you're using these tools. And we can think about what makes AI tools work well. I really love the simplicity of this diagram from Anthropic about how Claude Code works in three fairly simple phases of it gathers context, it takes some actions, it verifies its work, and then it goes around again until it's got something that it can present to you as the answer. And when we think about what we can do to make AI tools successful, we can kind of gather our actions into those three boxes. So in the topic of context, we can do things with the architecture and the documentation to make it work well. So if we have a kind of plugin-based architecture to our software, then what that does is that AI tools are really great at greenfield projects. They're less good at modifying existing code. But if you've architectured your software to a plugin kind of system, then all the AI has to do is understand the interface and then create new code for a new plugin for a new thing. We can break our system up into well-defined services that mean that when we're making a change, we only have to make a change in one particular place. We can make sure that the modules within our system are small and easy to understand. When it comes to documentation, we can make sure that we have an architectural guide that explains at a high level how the system interacts without having to read code and understand it from there, and also bringing in factors from outside the code base that you're looking at just now. And we can have summaries at the class level, at the module level, at the service level that help us to understand what's going on, and the AI can read these things and help it to do a better job. When it comes to tool use, the tools that command line based tools or command line based AIs are good at using are your basic Unix tools. They're very small, they're very focused, they have a simple interface, and the AIs can string these together in really wonderful ways. And it's a mistake to think that AIs would be great at generating a few hundred lines of JSON configuration that they can then throw at your software service to tell it to do a thing. It works much better if the tool calls are small and simple and easy for it to discover, and it can iterate them. It can call multiple times to achieve the goal rather than having to do one big thing. And it's helpful to have a kind of get and put nature to those services. So the AI agents should be able to query your service if you're trying to write a service for an AI to work with, and then they should be able to act on those queries. They should be able to find the information that they're looking for, and that shouldn't be, here's 10,000 records, AI, find the needle in that haystack. It should be able to make a series of queries of the kinds of things that it wants and deal with small amounts of data. And then when it comes to the verify phase, they need to be able to figure out that they've done the right thing. One of the interesting parts about that is that the choice of programming language comes into play there. The kind of typical examples that people make of AI, it's producing Python, it's producing JavaScript, and these are not necessarily strongly typed languages. But actually, if you do pick strongly typed languages, the AIs get immediate feedback from the compiler, from the type system, about whether or not they've done things correctly. So if you're working with Python, you can use Pydantic or whatever to make it more solid. If you're using JavaScript, you can move to using TypeScript. If you're already using Apex, then great, you're already in a strongly typed language. These things really help the AIs to get things right. And we can add linters and static code analysis, and all these give the tools more clues about what they need to do. And they're much better than trying to explain in a rules file what it is that they need to do. It gives them feedback so that they can take smaller steps each time they go around this loop. Obviously, tests, as we mentioned, if you can run your unit tests, then they can make sure that they've done the right thing. Coding style guides, we can tell them how they ought to write the code. And all of these things on this page, just like one of the earlier slides, these are all things that are good engineering practices. And if you're a sort of AI skeptic and you think that all of this might blow up, then again, if you write your software in all of these ways on this page, and then AI does blow up, what you'll end up with is well-architected software. So you've still won. So these things are more important than they ever were, and the AI is going to test how well you were doing these things. So we'll take a quick diversion into local minima and gradient descent, partly because it's something that classical AI algorithms used, and partly because it also helps you to think about ways of interacting with your kind of agentic programming AIs. My cat's scratching at the door. Sorry about that. So, local minima. So this is a sort of classic picture that we see from AI textbooks, where the aim of the game is to find the parameters that give us the best solution. So we can change values on the X and Y, the horizontal axis within that graph, and then we can measure how good a fit the solution is. So we're looking for the lowest point in that graph, and the AI algorithm can move us around that horizontal plane. And so it looks to minimize the error by doing a gradient descent algorithm. It tweaks X and Y, sees if the error has gone down, and if it has, then it sort of keeps going in that direction, roughly speaking. And where you end up depends partly on where you start. So if you start in point A in that diagram, and you just do pure gradient descent, then you will end up in that local minima, even though there's a better solution somewhere else. The other thing that affects where you end up is an idea called temperature, which is how far you allow the algorithm to let the error go up as it wanders around. So if you don't make it strictly always go down, then it might find a better solution somewhere else. So by increasing the temperature, you can hop over that saddle point and end up in the global minima. Now, I often think of what an AI coding agent is doing when it's doing some work for you as something like this. And sometimes you see it heading towards a dead end. So it's kind of tempting when you set an AI agent off to do a task for you to go off and make a cup of coffee and then just come back when it's finished. But if you watch its thinking process as it's printing that out to you, sometimes you can see that it's doing the wrong thing. So sometimes I'll see in its thinking process that it perhaps has started worrying about values that might come into a function that could never happen because I know they're checked somewhere else in the system. And I will just interrupt it and say, don't worry about that being null. Don't worry about checking that relationship between that thing. We've done that somewhere else. Just deal with the problem at hand. Or sometimes it's trying to help you with a failing test, and it starts changing the implementation, and you know the implementation is right, and it's just something to do with the test setup. And you say, whoop, stop, interrupt, move it over there. So it's really useful. And particularly as an English person, I don't really like to interrupt people. And I've kind of had to get over that and just like smash the escape. No, don't do that. Go ahead. Next up, I want to talk about AIDR, which I thought of myself, and then I found out other people have thought of it too. You're probably aware of TLDR, the internet acronym for too long didn't read. And AIDR is that sense when you start reading a piece of text, you know, this is clearly generated by AI and I don't think it's worth my time. And one of the things that came to mind when I was thinking about this is this quote from Harrison Ford when he was reading the first script from Star Wars. Apparently what he said to George Lucas was, you can type this shit, but you sure can't say it. It speaks to this kind of mismatch between sometimes it's easy to write stuff for other people and you're kind of shifting all the work to them. You can write a potentially terrible dialogue for Star Wars, and then the actors have got to kind of find a way to make that sound natural as they say it. And that can be a danger with us generating code or documents within AI. And I think the key thing to avoid getting stuck by all this is to make sure that you own what you made. And one of the risks with AI is this thing called satisficing, which is it's another kind of psychology term where people take the first solution that's satisfactory and they stop looking at that point, even if there was a better solution possible, if they were to continue looking. And it's kind of one of the first things you teach junior developers, like, don't stop as soon as it works in some sense. Continue to think about, is this the best solution? Is this the most minimal? And AI makes satisficing an even bigger risk because you get to that first solution so quickly and you haven't done the work to get there, so you don't know about the ugly bits of it. But we need to have that sense of ownership of the code and make sure that we don't stop at that point. We need to make sure that AI is not a tool that shifts the burden onto other people. Just because you can generate hundreds, thousands of lines of code per day and put those into pull requests, that shouldn't be an excuse to push that burden onto whoever has to review those things without you taking an appropriate amount of time on those. And text can have the same kind of sense of being uncanny and creepy as some of the kind of early AI images did. We had those pictures of people with too many thumbs or maybe an extra leg or whatever else, or just really weird eyes. And you'd look at it and you think, that's not right. And there is that sense with AI code and text sometimes that things are just not quite right. And not everything that an AI generates is uncanny and creepy, but some of it is, and you need to own it because it's going to have your name on it. Like, you will be held accountable for something that's generated. If you're going to push that into the code base, it is up to you. AIs are really good at generating code, and they're really good at generating README files and things. But if you start to read that code or that README file and your brain checks out and you just, oh, this is too boring, I can't finish it, you shouldn't expect your colleagues to finish it either. Like, get up, go for a walk, come back, read it again. And if you really can't make it through it, then you're going to have to revise it and get it to the point where it is more readable one way or another. So I want to talk about 3 different models of using AI. And this is kind of inspired by terminology from a guy called Cory Doctorow, who's a kind of technology activist guy. And he had this idea that the kind of nice, the positive way that we'd like to think of AI is acting like a centaur, like a half man, half horse, where we are the human part, we're in charge, and the AI is giving us a kind of horse body that allows us to charge around faster than we ever could before. And so we're the captain of the ship. The AI is doing the drudge work for us, and that's great. This is the ideal. This is where we want to be. But there's the possibility of ending up in the reverse centaur, where the AI is in charge, it's generating loads of code, and your job is just to review it and put your accountability onto the code that the AI has generated. And this is not where we want to end up by any means. And that's as far as Cory Doctorow took it, but inspired by the Gravity Falls cartoon that my son watches on Disney, there is also the Centaur Tour, which is 2 horses' bodies joined together. And this is a scenario where I have 5 bullet points that I want to send to Fede, but I'm a bit embarrassed about only sending him 5 bullet points. So I use AI to turn it into a big document. And then he receives that. And I'm not reading that document. And he gets that to trim it down to 5 bullet points. And they're not the 5 bullet points that I had in the first place. This is not a good way to use AI. And I think one of the points there is that if you're just using it to kind of embellish an idea and make it bigger, it's not adding any useful information at that point, and no one wants to read that stuff. So let's all aim to be the centaurs, not the other 2 options there. So one of the things that changes, something that's actually new in the world of AI that we have, is that code becomes cheaper. Some of it becomes incredibly cheap. So what should we do with it? Like, if code is super cheap, It doesn't always have to be good. Some code needs to be good, but not all code does. And one of the things that we can do is we can write scripts. Like anything in your dev workflow now ought to be scripted. The AI can generate you a script to do that thing. So just do it, check it in, and modify it later. These are pretty low risk things. They're great for A/B testing. Obviously, we can put up 2 different versions of a UI and we can see which one we prefer. One place where I've used it was trying to explore the behavior of Lightning Web Security and Locker Service and its strangeness, that I had one thing that worked and one thing that didn't. I could use AI to generate 5 different intermediary versions of this component that I was trying to make, and I could see which ones worked and which ones didn't to help me understand the weirdness of how Locker Service and LWS work. And I never would have written 5 different versions in the old days because it would have taken me ages. I would have slowly tweaked around with it for hours, but I got all the information much faster because I was happy to have cheap code that I was going to throw away. Migration by integration is another one. So if you need to do a data migration, kind of in my mind, the gold standard to do that is to create an integration between the old system and the new system. That's much safer than having, we're going to move all the data on one weekend and I hope it works on Monday. If we integrate it, then we can move bits of data piece by piece, and it's easier to roll back, and it gives us that kind of smooth transition. And if it's really cheap and easy to write integration code with AI, then we can do that much more often than we could before, and we don't have to have those kind of panic-stricken Sundays where we're hoping that all the data's gone across. Obviously, prototyping. It's the first thing everyone kind of talks about. AI can knock you up a prototype of something. You just have to be careful to make sure that doesn't become the production thing if it's not really solid. Things like microservices, they were all the rage a few years ago. Everyone wanted microservices, but if you can use AI to generate things like that, then that's great. You can define a strict contract around how it's going to work, and then no one actually needs to necessarily look at the code inside that service ever again. As long as it fulfills its contract, then that's great. Little pieces like that are good. Diagnostic debugging is another interesting one. I was working with some infrastructure as code stuff, and we were having some networking issues about whether or not we could reach a particular resource. And there are 100 things that can go wrong about how you set up your virtual network and your firewall and everything else to make that service available. And what was super cool was the AI agent could generate a diagnostic script for this networking problem, which would go through step by step all the things that needed to be right. So I could check off all the things. And as I updated things, I could rerun the script and I could see my progress getting closer and closer towards being able to reach the resource. And I think without AI tools, I would have been manually poking through that stuff. But my kind of feedback and iteration cycle, because I had a script, was much, much better with that cheap, fast code. So thanks for persevering. A few final thoughts on this. AI is definitely happening, and it's not going away. It might be a bubble, but there are open weights AI models that are out there and will run on your laptop. So if OpenAI and Anthropic and the rest all burn down tomorrow, we'll still have some form of these tools here. So we can't deny that this thing is happening, and we can't think that the genie's ever going back in the bottle with this stuff. There's a possibility that we'll end up with more software than we ever did. There's an idea called Jevons paradox, where the idea of that is if you make something cheaper, people can end up using more of it. So if you take an example of if your test suite takes an hour to run and it uses loads of compute resources on your server, then you might think what we need to do is speed up that test suite, and then it will cost us less on the server. But what typically happens in that scenario is that your developers go, oh, the test suite's faster. I'm going to run it more often. So you can end up consuming more resources by making that thing more efficient. And that's Jevons paradox. And it may be that with code, if we make code cheaper and easier, we just end up with tons more of it. And it may be that we need more software engineers and architects to wrangle all of this stuff, I hope, or we're all out of a job. But hey, it's positive potential for that. And I think it's important to follow the development of AI from a kind of appropriate distance. A lot of the things that were early tricks have become baked into the tools. And so if you kind of follow a few AI influencer people, some of the things that they say are quite interesting. Like I remember early on with these tools, you would have to say to ChatGPT or whatever, you're an experienced software engineer, you do this, you do that, and now tell me how to do the thing. And no one really does that anymore because the tools got to the point where they already have that kind of characteristic, or they don't need that kind of treatment. And then a few months ago, everyone was saying, okay, well, the thing to do with a coding agent is tell it to make a plan before it starts coding. It needs to make a plan before it starts. Tell it to make a plan. And then pretty soon after that, Cursor and Claude Code just automatically started making plans without you even asking it. It would say, here's my plan, and then I'm going to tick it off while I do it. And then only in the last few weeks, people were saying, instruct it to come back and ask you for more information before it starts planning, if it needs you to give it more inputs. And now Claude does that. If I ask it to do a thing, it will say, it will ask me about the context and the approach that I want to take before it finalizes its plans. So if you're following a few steps behind the cutting edge of AI, then you get all of these advancements for free. They just turn up in the tools. And I think using the relatively boring tools from the main providers is kind of the sweet spot there of, you get these things eventually by the time they're tested. And the difference between you and the Twitter influencers is like weeks. It's not a long time. And you can just kind of get on with your day, being productive with these tools, and come in and go, oh, that's clever, doing a new thing. And that's kind of it. That's what I had to say about the AI tools. As I said at the beginning, it's very no one knows what they're doing. So it's really great with the community groups that people can exchange what they have been doing with these things and understand what they're good at and not good at, all the techniques. I'd love to talk to you guys who are listening to this and hear about what you're doing. I wrote a blog post, which a lot of the same points as we've been saying here, some different ones, but if you'd like to, please do. Yeah.
Very nice. Very interesting. Thank you. Thank you very much. I have a few questions.